In this chapter, there are four main parts. The first part starts off talking about static electricity. After that, it talks about what is current and current flow. Then you have potential difference. Finally, you have resistance. There's quite a lot of formulas in this chapter, but let's go through step by step, starting off with the first part concerning electric charge. So what we have learned before is that we have seen the atomic model, right? This is mostly something that you've seen back in lower sec, correct? But generally, what we do know is that hey, inside an atom, there's going to be my proton, neutron, and electron. And as you can see over here, the protons are positively charged and the electrons are negatively charged, right? Pretty straightforward. And that is pretty much what we need to talk about. There are positive and negative charges, but the way to quantify the charge is I'm going to use this SI unit called coulombs, right? So charges, coulombs. Coulombs are written with a capital C, right? So what happens if I have a lot of negative charges? What happens if I have a lot of positive charges? Well, that makes me either positively or negatively charged. Now, to be very, very clear, what makes me negatively charged is the fact that I have the presence of more electrons than protons. Now, in this case over here, you see there's an equal number of protons and electrons, right? So if I am to be negatively charged, right, it means that let's say I have less protons than electrons. So if I have excess of electrons, then that means I'm negatively charged, right? Likewise, if I have the lack of electrons, that means I have more protons, then I'm positively charged. So the idea is really talking about looking at the number of electrons that we have. Now, if I were to put two items, one atom over here, one atom over here, one atom there, let's say this over here has excess electrons, so they'll be negatively charged. And this item over here lacks electrons, so there's more protons, so it'll be positively charged. How do they interact? Well, I do know that these two are unlike charges. Unlike charges will attract. And of course, if you have like charges, let's say both are positively charged or negatively charged, in this case, both positively charged, they will, oh dear, they will repel, right? So that settles for this first part over here, talking about there's positive, negative charges, they measured in coulombs, and unlike charges attract, like charges repel. How does this come out in an exam paper? It could be something like this, right? Let's go over here. So in this clip, you see a little girl sliding down, and as she slides down, she starts to pick up a lot of static charges, and her whole head, her whole body is full of, let's say, negative charges. And oh, all her hair starts to spread apart, right? Why is her hair spreading apart? Well, then you would say something like, all of the negative charges are on her head, and because each strand of hair has the same charge, all the like charges are going to push apart and they repel. Therefore, the hair starts to spread apart and push each other apart, right? Something as simple as this. Okay, so that's for static charge. Again, this is just meant to be an overview, not really teaching the whole chapter. So that's for A and B. Now, how does this move on to current of electricity? Is that now that we know there are things as charges, right? What then do we understand electric current to be? Electric current is then simply charges which are flowing. And how then would I have a high current compared to a low current? Well, this really current is the rate of flow of charge. That means how fast or how much charges flowing per unit time. So current is a rate of flow of charge. So there's charge per unit time. So what we will have to do is to understand them in terms of my symbols, in terms of my formulas. So how does it usually look like? It looks like current I is equals to charge over time. Or as we usually write it in class, Q equals to IT, right? So what does it all stand for? The symbol Q in the formula stands for my charge, SI unit is coulomb. The symbol I stands for current, SI unit is amperes. And time, as you already know, that's going to be seconds. So the first thing we're learning for this part in C is that, hey, I have something new here. I have this new SI unit. So we have first our SI unit coulombs, that's for charges. Now we have amperes for current. Right? How do we see current if moving inside a circuit? So that's the next part over here. Distinguish between conventional current and electron flow. What is that? Let's go over here. Here we have a circuit diagram representing my dry cell, where the longer line is positive, the shorter is negative. How we can remember is because positive must go like that, yup, yup, right? So that's two lines, right? Or if you rearrange it, it goes like that, right? Negative is just a short one, so just like that. That's one way of remembering it. So this is positive, this negative. In this circuit diagram, this circle, what on earth did I just do? Oh no, let me draw it again. In the circuit diagram, there we go. All right, this circle and the cross over here makes it represent a light bulb. All right, so we will have electric current flowing through. So which direction is conventional current flow? Conventional current flow would be from positive to negative, right? Now, electron flow, which what we now know, because electrons are actually the ones that's flowing, positive charges can't flow, only negative charges can flow, right? Because only electrons can move. Protons can't move, they stay in the center, right? Electron flow actually goes the opposite direction. So using this, it goes this way, in the opposite direction, right? So you go here and this way, from negative to positive. That's electron flow, but as far as you're concerned, current flows conventionally from positive to negative, right? So if the question asks you, hey, in this diagram, can you please tell me which direction is the electron flow? Look for the negative sign, because electrons go away from negative. Remember, negative charges, like charges would repel, right? So electrons don't want to be here, they want to go here. That's electron flow. Just remember, this was all done before the discovery of electrons, so give them a break. All right, one more thing to note is how do we measure it? We measure it using an ammeter, but that will be covered more in the next chapter of DC circuits, so let's not go into that yet. All right, back here, we have talked about C, we have talked about D. Now we need to move on to the next one. I just realized that this is still playing. Let me stop it first. There we go. Back here. During the exam, they may tell you, right, that, there's a certain amount of charges flowing in a certain amount of time. Let's say we have something that's simple. Okay, let's say, for example, that there is 50 coulombs flowing through the wire or through the circuit in 3 minutes. And ask you, hey, if that's the case, what is the current? So how do you do that? I know that I have a formula, Q equals IT, and I'm trying to look for I, correct? So let's make I the subject. So I equals to Q over T. What is Q? Q stands for charge. So there's this one, 50 coulomb. And the time that I'm given over here is 3 minutes, but I must remember that the time must be in SI units, seconds. So to change this to seconds, which is 3 times 60, and the answer is 0.28 amperes in 2 sig fig, right? This is judging from the fact that I have 2 sig fig here. I think that should do it for current, and we're done with this too. All right, let's move on to the next part, which is talking about potential difference. Now, it does start with this other thing where we see this word over here, electromotive force, right? So what is that?